Here we're going to determine whether 3, negative 2 is a solution to this linear inequality. So if you don't know how to read inequalities, make sure you watch the video before this one where I go over the basics of understanding linear inequalities and how to read linear inequalities. So the only way I'm going to determine whether 3, negative 2 is a solution is by plugging it into the inequality itself. We were given a 3 for x, so we're going to remove the x and replace it with a 3. We were given a negative 2 for y, so we're going to remove the y and replace it with negative 2. Once we do so, it's going to look like so. Negative 2, but with a negative in front of it, becomes plus 2. 3 plus 2 is 5. Once you get it to where you have one number on one side and one on the other, you read the inequality. This inequality says that 5 is greater than 5. Well, that's a false statement because 5 is not greater than 5. So that means that the order pair that we plugged in, that 3, negative 2, it is not a solution to this linear inequality. Let's use that same inequality, but just use another order pair. How about trying 7, 1 and see if it's a solution? So we're going to remove the x and replace it with a 7, remove y and replace it with a 1. When we do so, it's going to look like so. Let's do the math on the left side. 7 take away 1 is 6. When you get it to where you have one number on one side, one on the other, you read the statement. 6 is greater than 5. 6 is greater than 5. That is true. And because that is true, that means that yes, the ordered pair 7, 1 is a solution to this linear inequality.